All right, our last lesson in this unit on probability is going to be on counting outcomes and something called the fundamental counting principle. In your table of contents, go ahead and add the title for today's lesson, Counting Outcomes. And then on the next clean sheet of notebook paper, write the title and then the essential question for today, which is how is the number of outcomes of a multi-step process related to the number of outcomes for each step? Go ahead and set up your table of contents in your notes, and then when you're ready to move on, you can hit play. All right, what is the counting principle? Sometimes we see it called the fundamental counting principle. Copy this into your notes, the counting principle. If there are M, and M will be a number, possible outcomes of one action, and N will be a different number, possible outcomes of a second action, then there are M times N, we're going to multiply those numbers, outcomes of the first action followed by the second action. So for example, if we are looking for a combination of a shape and a color, how many choices do we have for the shape? 2. How many choices of the color do we have? 3. We multiply 2 times 3 and we get 6. So there's 6 total possible outcomes. If we had counted up from our sample space of our compound events in the last lesson, how many possible outcomes, this is the number we would have gotten. Some questions, they want to actually see the sample space written out with all the different combinations like we see it here. But then on different questions, they may just say how many outcomes are possible so we don't have to go through this big long process of listing everything. And that's when this fundamental counting principle is helpful. Okay? So let's try this example, and I want you to do this with me in your notes. Call this example 1. We are looking at the number of outcomes for the class election. So we are making 3 choices. We are choosing president, secretary, and treasurer. How many choices do we have for president? We have Marta or Ethan, so that's 2. How many choices do we have for secretary? We have Ben, Rosa, and Zach. That's 3 choices for secretary. And then we have 2 choices for treasurer, Andy and Theo. So then we just multiply 2 times 3 is 6, times 2 is 12. So there are 12 possible combinations, 12 possible outcomes for the election. Okay, it says we could check our result by writing out the sample space for the election. I'm not going to take the time to do that. We could do that by going through and saying Marta, Ben, Andy, Marta, Rosa, Andy, Marta, Rosa, Theo, like all the different combinations here. But I'm not going to do that since we learned about that in our last lesson. But we could. All right, at Charlie's House of Chili, your chili can be mild, medium, spicy, hot, or super hot, and you can have it with or without cheese. How many different ways can you order chili at Charlie's House of Chili? Try this one on your own, or hit pause, find your answer, and then you can check your answer with me when you're done. So how many decisions are we making here? We are choosing the heat of our chili and then the cheese of our chili. We have 1, 2, 3, 4, 5 heat choices, that's 5, that's my first decision, and then with or without cheese, that's my second decision, 2 choices there. So how many different combinations? 10 different outcomes. And I could list them out if I wanted to. Okay, given the sample space of an action, you can identify outcomes that have particular characteristics. These outcomes compose an event in the sample space. So, in the sample space that we've already learned how to list out, here's the sample space over here. In the sample space, if we toss a coin and then roll a standard number cube, these are all the possible outcomes, heads or tails, and then 1 through 6. The event of toss tails or roll an odd number means that it's going to either be a T or an odd number, or it might be both. We would select all of those choices from our sample space that have either a T, so all 6 of these, or an odd number. So then I would add in the 1, the 3, and the 5. Okay, so there's 9 outcomes in the event of getting tails or an odd. All right, so which of the outcomes in this example, we looked at this example and drew this tree diagram yesterday. So we're just going to do this new part of the table. Do this with me in your notes. Which outcomes from that erase this over here real quick. And now we're looking for combinations where we have at least 2 girls. So, no, no, no. This is my first one where I see 2 girls. So, boy, girl, girl. Here's my next one. Girl, boy, girl. Okay. Then I could have girl, girl, boy. And then since it says at least 2, I could have 3 girls. Girl, girl, girl. That's 4. So make sure you have that little table completed in your notes. Call that example 2. Okay, use the table of possible outcomes, and it was nice of them to give that to us already, so we don't have to do it. By rolling 2 standard number cubes, how many outcomes are in this event? We actually did this in our little activity when we were doing the counters game. Do you remember? How many sums of 7 can we possibly have? Well, let's look. Sums of 7. 3 and 4. 2 and 5. 4 and 3. 5 and 2, 6 and 1, 1 and 6. 1, 2, 3, 4, 5, 6. How cool is that those make up the diagonal of the table? I know y'all are really excited about that. There's 6 outcomes where we can get a sum of 7. And that is the most common sum from rolling 2 regular dice. Okay. In how many different ways can Alice, Becky, Carl, and David place first, second, and third in the race? I'm going to teach you a trick on this one. Call this example 4 or whatever we're on. Okay? Work this one with me. So which places are we talking about here? We're looking for first, second, and third place. I want you to draw a line. First, second, third. Write this down. This is a little trick to help you find this. All right. How many possible ways can I get first place? How many choices do I have for first place? I have Alice, Becky, Carl, and David. That's 4 choices. Now, if somebody wins first place, they're out of the running for second place. So how many choices would I then have for second place? 3. So now we've already gotten our first place person and our second place person. They're out of the race. So how many choices do I have for third place? 2. And then we just multiply. 4 times 3 is 12, times 2 is 24. There's 24 different ways that we could get first, second, and third place. Why would I not do 4 times 4 times 4 there? Because once somebody wins first place, they're not going to be also getting second or third place. Okay, so we have to take that down by 1 each time. And then it says, in how many different ways can Alice finish ahead of David? We would have to list out the sample space and then look for the ones where A comes before D. Okay, password questions are always a type of question. It's not so difficult, but I have to get you to use my little trick like what we just did in the last problem. So make sure you do this with me in your notebook. This is example 5. Okay? And that they're going to tell us to choose a 3-character password. Since we are choosing 3-character password, I want you to draw 3 lines. Okay? 3 lines for the 3 characters. Selecting 2 different letters. So I'm going to write under the first 2 that they are going to be a letter. And then followed by 1 number. So I'm going to write number. Okay? Alright, and the letters and the numbers have to come only from this. So we're not thinking the entire alphabet / number system. We're just choosing from those letters. How many letter choices am I going to have? I have 1, 2, 3, 4, 5, 6. I have 6 different letters that I can choose from. And then for the second letter, since they tell me that I have to use 2 different letters, if I already used a letter in the first character of my password, and they want it to be different, that means how many choices do I have left for the second letter in my password? I've already used 1 letter, so I just have 5 choices now for the second letter. And then how many number choices do I have? I just have these 2 choices. So I put 2. And then I multiply to find the total different number combinations. So 6 times 5 is 30, times 2 is 60. 60 different combinations of those letters many of them begin with the letter K. So to find this, how many begin with the letter K, if they're telling me what letter I have to use for the first letter of my password, how many choices do I have? If it's going to be K, I just have one choice. K. Okay? So we use the K here. Then the other 5 letters are our choice for the second one here. So how many combinations can I make with the letter K? 1 times 5 is 5, times 2 is 10. There's 10 different passwords I could use the letter K as my first character with. Okay, now finding theoretical probabilities when we're dealing with compound events, either independent or dependent events. Remember our formula for theoretical probability. It is the number of favorable outcomes over the number of possible outcomes. So first, if we are going to spin a spinner twice, we know this is independent events because the spinner is not going to change from the first spin to the second spin. You would list out the sample space to find the total number of outcomes. So red, blue, or green is the first option, and then from that, the second spin, red, blue, or green. So 3 times 3, there's going to be 9 possible outcomes, and then they want to know, spinning the same color twice. We could get red and red, blue and blue, or green and green. There's 3 different ways that I could get the same color twice out of 9 possible outcomes. So that would simplify to be 1 over 3. Okay, looking at this table, they have given us the sample space of the combinations of the fish, star, apple, key, and leaf cards. We're playing some kind of a game, I guess. All right, what is the probability of at least 1 apple? Well, first I need to know how many possible outcomes I have. And I see that this table is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So 5 times 5 means I have 25 different combinations together. So that's going to be the bottom of my probability. How many of these have at least 1 A apple? I'm just going to circle them because it seems easiest to me. Looking for all the apples. I think I got them all. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 25 would have at least 1 apple. Then it says exactly 1 apple. So which one would I have to get rid of then? Can't have this guy. If it has to be exactly 1 apple, that would be 8 out of 25. All right, next, exactly 1 apple and 1 fish. So I want apple and fish, A and F. I have this one, and I have this one. So that is 2 out of 25. And then at least 1 apple or fish. So now I can have 1 apple or fish. So I'm going to have the 9 that I already had. Those all had apple. And then I'm going to add to that the fish, the F. So F, 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 and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of 25. All right, I'm going to flip to a second video just so we can finish this lesson real quick. There's not much more.